Okay, welcome back, guys. We're going to finish up our material for immune system today. So we're all finished with that. Here's where we left off. We're talking about immune system challenges. So yesterday, or last video, we were talking about the idea behind how human history and human evolution regarding our medical technology has improved the immune system via antibiotics and via vaccines. Now we get to talk a little bit about some challenges that can affect the immune system. So this is actually referencing the very first video we recorded. We were talking about if you catch a common cold, what happens, right? Now, if you've been following along with these videos, you'll know that when you catch a cold, eventually your body fights it and deals with it, and then you're supposed to build immunity. So why is it that you can catch a cold again? Well, there's two major reasons. There are over 100 different known rhinoviruses, so because there are so many of them, there's a good chance you can encounter different strands over and over again. And most importantly, cold viruses can mutate quickly. They have the ability to mutate very rapidly. So because they can mutate so rapidly, there's a low chance you're going to build up immunity to just what's known as the common cold. That's kind of why we call it that, right? No sooner do we have immunity to one form, then along comes another. How do I get this cold? To catch a cold, a rhinovirus must reach the mucous membranes of your upper respiratory system. So it primarily affects the upper respiratory, which is anything from neck up as far as respiratory system. And if you're thinking about it, mucous membrane, that means it's primarily going to target your nose and your nasal cavity. You have most of your mucus in your nasal cavity anyway. Your hands pick up rhinoviruses from surfaces. Every time you touch your eyes or nose or eat something with your hands, the viruses get a free ride. It's not because you have to become a germaphobe, but just in general, practice good hygiene. Wash your hands every once in a while, right? Viruses may also ride on recirculated air or reach you if someone sneezes right at you. This is a big reason why, especially with the pandemic going on, at least currently, there is a ton of one of the best things you can do to help spread the infection of viruses, especially airborne viruses, would be masks. By wearing a mask, you prevent the spread of this stuff because it slows down the transfer, especially like droplets, which is how COVID-19 transfers. So you can slow down the transfer of that. So again, you have to be very careful with like enclosed spaces and people around you, especially if there's an ongoing pandemic. Cold myths. Cold and the flu are different illnesses. Not every respiratory infection is the flu. So I'm just going to go ahead and start that because we've talked about that a couple times now. These are not the same thing. Just make sure you can identify a common cold is not the same thing as the flu. Not every respiratory infection is the flu. Colds are not caused by getting chilled. This belief comes from medical ideas of prior centuries when it was believed that illnesses were caused by an imbalance of humors and that a person with a cold actually had too much coldness. So it's not literally like you're too cold, so you get a rhinovirus or you catch a cold. That's not how that works. Although there's some validity to that concept. So you've probably been told before at some point, like you're walking out and it's 40 degrees outside and you're wearing shorts and a t-shirt. And your parent may tell you, are you trying to catch a cold? What are you doing? It's not because a rhinovirus is more active when it's that cold. It's more so that when your temperatures dip, when you're below your homeostatic temperature of 98.6 plus or minus 1, let's say you're at 95, 96, that's pretty cold for your body. Your immune system is now not as active or not as efficient as it could be. So if that's happening, then yes, you have a higher chance of getting sick. So that's what we observe here. How do we differentiate cold versus flu? And in fact, you can even differentiate it versus COVID-19, which is a respiratory infection similar to flu. It's not a flu type virus, but it has similar symptoms. Well, you look at the symptoms overall between these two major ones, right? As far as cold versus flu. Look at fever. Fevers are rare in colds, more characteristics amongst flu. Headaches are very mild in cold, although they can be strong in flu. So you want to be observant of that. Aches and pains, so malaise is not too prominent in cold, but it can be usual and strong achiness in a flu. Fatigue is not too common in a cold. It's more mild fatigue. 2 to 3 weeks of fatigue, which is low energy in flu. Exhaustion is not very common. It's very prominent amongst flu, which is basically you're resting, but you don't feel rested. Stuffy nose, sneezing, and sore throat, that's all stereotypical of a common cold. Chest discomfort, not too much with a cold, but flu, it is much more common. It is much more common. So how do you differentiate? Because the symptoms sound pretty similar. Well, with the common cold, You just have to remember that it is a virus affecting your mucous membranes. And where do you have most of your mucous membranes? Your nose. You're going to have most of your mucous membranes in your nose, so that's going to cause a lot of that stuffiness and sneezing and a little bit of sore throat. That's a common cold. A common cold is not supposed to knock you out. Flu can knock you out. Flu will be something that you're bedridden for a couple days. So it's pretty potent. COVID is similar to flu in the context of the symptoms, but the biggest thing that COVID has that flu does not, as far as symptoms, is you lose your sense of taste and smell. So you can lose your sense of taste and smell, and that's one of the key distinctions. How do you confirm either way? You just get tested. You can get tested for flu, you can get tested for COVID now, so you just get tested. What about this concept of a stomach flu? I'm sure a lot of us have heard of that. But here's the thing. Flu, remember, is influenza. Influenza is a strictly respiratory virus. So there is no such thing as a stomach flu. It's just a nickname. And technically, it's an incorrect nickname, but it's a nickname nonetheless. There are viruses that can attack the digestive system, norovirus and rotavirus. These cause nausea, vomiting, and diarrhea. Many people call that stomach flu. If left untreated, the rapid dehydration these viruses cause can be fatal. I mentioned this previously, but diarrhea is one of the leading causes of death in the world because in a lot of impoverished countries, they don't have the resources to be able to replenish their fluids as rapidly as needed, and that could kill you, especially for young children. This, however, happens all the time, regardless of what country. Food poisoning. Bacterial food poisoning can also cause fast onset vomiting and diarrhea. So, food poisoning is typically more prominent amongst bacteria. So, it depends on where you're eating, right? You can get food poisoning technically from a 5-star restaurant, but the odds of getting food poisoning from a place where where they are more serious about how they prepare the food and cleanliness and everything like that, are much less than eating theoretically like fast food or like gas station food. Evolution of the flu. So I've talked about this in our last video as far as like flu vaccines and why flu vaccines can be so difficult because of their unlikeliness, right? It's a gamble of sorts, and the reason for that is because the virus mutates so quickly. The virus has an ability to mutate very fast. This virus also has the ability to crossbreed. It can jump to other animals, as you see here. Different forms, and the problem with that crossbreeding is that different forms of this virus may then hybridize to make a new strain altogether. And that's what you see happening in this picture. You could have a human individual sick. You could also have a bird that's been sick, which we call this avian flu. Those two strains can combine to now form a new strain, which could infect other animals as well, including humans, and that could infect like pigs, which we call that swine. Speaking of, flu pandemic. This was a massive pandemic. It killed millions of people. If I remember correctly, it was total to be around 5 million people, close to 680,000 in the US alone. But this was a super deadly pandemic that occurred in 1918 called the Spanish flu. So regarding this, it was recently identified that it was associated to an avian flu. That's actually what made it so deadly. Unlike the common flu, it was not attacking primarily elderly individuals and very young individuals. It was attacking mainly young and healthy people. So because of that, it became really rampant, and it didn't help that World War I was happening at the same time. The recent H1N1 flu was mostly a swine flu, but it had some avian genetic markers similar to this 1918 pandemic. So that was really concerning. A lot of epidemiologists were very concerned that this was going to be a massive pandemic again with H1N1. Thankfully, we kind of dodged some bullets with that. But of course, now we're dealing with that with regards to COVID-19, which is not a type of influenza. It's more of a type of SARS virus, but they're both respiratory conditions. Autoimmune disorder. If you don't know what an autoimmune disorder is, you should be aware of it. Autoimmune disorders are disorders in which your own immune system attacks itself. So basically, your immune system is supposed to protect you, but in this case, your immune system is hurting you. A couple examples of autoimmune disorders. We've actually talked about one of them before. Multiple sclerosis. We'll talk about that when we do nervous system. Lupus is a pretty bad skin condition. And then rheumatoid arthritis. We talked about that when we did skeletal system. Arthritis is the inflammation of the joints. In this case, your joints inflame, and then your immune system attacks your own joints. As you can imagine, not good. None of these can be cured, but drugs can help slow the progression of these diseases. So autoimmune diseases are so difficult to work with because they hijack your immune system. It's hard to cure something like that. You instead have to take medication to try to sustain it and try to live with it. Cancer. We've talked about cancer a number of times. We've talked about cancer in regards to lung cancer, skin cancer, bone cancer. So we've talked about it a number of times, but if you didn't know what cancer is by definition, here it is. Cancer occurs when the mechanisms that control cell division fail and body cells divide out of control. So if the cells are dividing rapidly out of control, that is considered cancer. The good news is you normally have killer T cells or cytotoxic T cells to recognize and destroy these cells. And I've mentioned this previously. Most of us will have cancer hundreds of times in our lives, but your killer T cells will go out of their way to destroy these cells. So they do a good job of destroying them before they ever become a problem. But if division is too rapid, so if they grow too fast, the T cells physically cannot keep up. If they can't keep up, then that's when you consider it like diagnosable cancer. Some cancer research involves assisting cytotoxic T cells in recognizing and destroying cancer cells. So that's pretty important too. There is cancer research conducted to help boost your killer T cells, their effectiveness, to hopefully destroy the cancer cells before they ever become a serious issue. That's the hope, at least. AIDS. If you didn't know what AIDS stood for, it stands for Acquired Immune Deficiency Syndrome. Not a bad idea to know that. It's caused by an infection by this virus, human immunodeficiency virus, or HIV. So you get you get HIV, which is a virus, and then that can cause AIDS, which is the syndrome. AIDS attacks and destroys helper T cells. That's what makes them so problematic. Because it attacks the immune system directly, finding a vaccine has been difficult. If you remember from our video 2 videos ago, we talked about that helper T cells, their job is to initiate the immune response. They activate the adaptive immunity, as we call it. If those cells are destroyed, then you basically don't have any adaptive immunity, and thus you are very prone to infection. You can get sick a lot and get really sick. Some drugs slow down HIV reproduction, but no cure exists yet. Prevention is still the best cure. The advancements with medicine with HIV have gotten really good. HIV used to be a death sentence. Nowadays, you can live with HIV comfortably as long as you understand, what you're dealing with and the medication that you're taking. How does AIDS actually do its thing? HIV will fool helper T cells into thinking the proteins are self, so they belong. And so it is able to infect the cells that trigger specific immunity. So literally here, you see in green, that's all a helper T cell. In red, that's a ton of HIV viruses. It convinces the cell that it belongs there. So then the virus will hijack the T cell, make more viruses, and then kill the T cell when the new viruses burst out. That's what you see happening here. In this picture, everything on this red is a hijacked killer T cell or hijacked helper T cell, and then it's releasing viruses before the cell blows up. Regarding prevention, HIV is a fragile virus that cannot live outside the human body for more than a few minutes. That's really good. It doesn't survive very long outside. Preventing HIV spread comes down to preventing exposure to body fluids of an infected person. So that's also important too, knowing what fluids can cause it. So in regards to that, the most important fluids that you have to be careful with is blood and sexual fluids. No doubt about it. That said, can you get HIV from someone from hugging them? No. What about kissing? Saliva normally doesn't carry HIV, but if that person who you may be kissing has like a gum infection or like gingivitis where their gums are swollen and they may be bleeding, it doesn't have to be blood that's physically seen, like that you can see it. It could be microscopic amounts of blood in the saliva, and that could get you sick. So you have to be careful with that. Finally, to conclude, SCID. SCID is a pretty serious condition, severe combined immune deficiency. It's a genetic condition in which one or more genes for proteins crucial for the immune system are defective. So you can summarize all of that into this next sentence right here. Children born with SCID have no immune system. So children born with this condition have no immune system whatsoever. And you can imagine why that's a problem. No immune system means your body cannot defend itself against the plethora of bacteria and viruses and germs that exist in the world around us. Gene therapy has been used to inject a good copy of the defective gene into blood cells or bone marrow cells. In several cases, this has been effective, though it is still experimental. So there's no vaccine for this. There's no medicine for this. This is something that requires affecting the genes directly. And in theory, that's possible. You could use gene editing tools like CRISPR to possibly do this, but it's all theory, right? It's a lot of experimental stuff. Thankfully, this is a rather rare condition. This doesn't happen often. But nonetheless, this is a serious condition because no immune system means your body cannot fight off the hundreds of things that you encounter on a regular basis. Okay, so that's where we're going to conclude. That is immune system. Not bad overall. Like I said, pretty short unit, right? So I appreciate you guys checking in. Thanks so much for that. Otherwise, I'll check you on the next one as far as our next video. So have a great rest of your day.